The goal of this video is to learn how to solve a system of equations in 3 variables with 3 equations. Okay, this can be very similar to solving a 2-variable system where we're going to use methods of substitution and elimination. Here's an example of why you might need to learn how to solve a system of equations in 3 variables. Okay, let's say I asked you to find the equation of the parabola that passes through 3 points, -240, 1, 7, and 315. Now, while this doesn't look like a system of equation in 3 variables, the only way to actually find the equation of the specific parabola that goes through those 3 points is to set up a system. So we know every parabola can be written as y equals ax squared plus bx plus c. If we can substitute in y and x, then we still have 3 variables we don't know for the equation of the parabola. We wouldn't know a, we wouldn't know b, and we wouldn't know c. And anytime you have an equation with 3 unknowns, you're going to need 3 variables. Just like a 2-variable system, you'd have 2 equations. Okay, so if I can substitute in my x's and y's, I'll have 3 different equations to set up a system. For example, okay, if x is -2 and y is 40, then my equation becomes 40 equals my x squared, which is -2 squared, times a, plus my x times b, plus c. Okay, so I still have 3 unknowns, because I don't know what a, b, and c are because I don't know the equation of the parabola. So if I have 3 unknowns, I need 3 equations, which is why you need at least 3 points to define a parabola. Because if you want to find a, b, and c, you need 3 different points. It's another way to look at it. Okay, so our next point would be 7 equals 1 squared times a plus 1b plus c. And my final equation is 315, so 15 is my y, and 3 is my x. I could put those in parentheses if I want. It doesn't really make a difference. Okay. So simplifying this up, we now have a 3-variable system. So my first equation is 40 equals, well, -2 squared is 4, so this is 4a minus 2b plus c. My second equation is 7 equals, well, 1 squared is just 1, so this is just a plus b plus c. And my third equation is 15 equals 3 squared is 9 plus 3b plus c. Okay, so in order to find an equation for a parabola, we need at least 3 points to solve for our 3 unknowns, a, b, and c. So this is an example of a 3-variable system here. And in order to solve a 3-variable system, my recommendation is to turn this into a 2-variable system and then solve that 2-variable system like you would any other problem. So our goal is to turn into a 2-variable system. Now, if you have 2 variables, you'll have to have 2 equations. Okay, so basically what we want to do is get 2 of these equations, it doesn't matter which 2, and get them in terms of 2 variables. So instead of a, b, and c, can we get it just in terms of a and b? Okay, if we can do that, then we have a 2-variable system, and we know how to solve a 2-variable system. So it doesn't matter which 2 you choose. Pick 2 strategic ones. Maybe I'll just work with equation 2 because it's just a, b, and c. Those coefficients are easy to work with. And maybe I'll work with equation 1. Okay, so I'm going to rewrite these over here. My 2 equations are 40 equals 4a minus 2b plus c, and 7 equals a plus b plus c. Now, in order to turn this into a 2-variable system, I'm going to have to eliminate one of my variables. And you can choose which method you prefer here. If you like substitution and you think substitution is easy, then substitute one variable in for another and then get a 2-variable system. If you like elimination, then use elimination. And I'm going to choose to use elimination because I find that that's my preferred method, but it doesn't really matter what you choose. So in order to choose elimination, essentially what you're going to do is you're going to add the 2 equations together, but you have to add them in a strategic way such that one of the variables gets eliminated. So right now, if we just added these 2 equations together, nothing would cancel out. So in order to get something to cancel out, we have to multiply either one or both equations by a factor. So for example, I could multiply this equation by 2, and then you'd have 2b, and -2b, those would cancel. Okay, or you can multiply this whole equation by -1, because if you multiply by -1, you'll have a plus c up here and a minus c down there, and those 2 equations would eliminate. That seems like the easier option to me, so that's what I'm going to do. So this equation is going to stay the same. I'm just going to rewrite that. And this equation will become negative 7. And don't forget, you need to distribute to all parts of the equation. Don't forget any part. Even the 7 over here, okay, on the other side of the equal sign, still needs to be multiplied. So this will be negative 7 equals negative a minus b minus c. And now if you add those two equations together, your c's will eliminate. So 40 plus negative 7 will give you 33. 4a minus a, or 4a plus negative a, will give you 3a. Negative 2b plus negative b will have negative 3b's, and the c's eliminate like we wanted. So now I have an equation with two variables. Unfortunately, solving a three-variable system requires a little bit more work, because right now I haven't got a value for a and b. All I have is an equation that's in terms of two variables instead of three. So while I've made progress, I'm not quite there yet. If I want to solve this equation for a and b, I have two variables. That means I need two equations. So I can't solve this system just yet. What I'm going to need to do is find another equation that's in terms of a and b so I can solve a two-variable system. Okay, in order to get this equation here, I combine my first equation and my second equation. Like I said, I'm going to need one more two-variable equation to solve the system. So first, I picked this equation, second equation, and I came up with a unique two-variable equation. So I need to do that process again, but I need to pick two different equations to combine. So maybe I'll pick, instead of 1 and 2, maybe I'll do 2 and 3. Now, I keep using 2, the second equation, because I like that it just has an a, b, and c. But I could also do a combination of equation 1 and equation 3. It's up to you. I'm just trying to pick what's easiest. Now, I keep talking about equations 1, 2, and 3. Maybe I should actually label them. So we'll call this equation 1, this equation 2, and this equation 3. Okay, so first I combine equation 1 and equation 2, and now I'm going to combine equation 2 and equation 3. So equation 2 is 7 equals a plus b plus c. Equation 3 is 15 equals 9, there should be an a there, 9a plus 3b plus c. If I can combine these like I did up here, I can come up with another two-variable equation. Okay, so you can choose. You can do substitution or elimination. And substitution would not be too hard here. You can isolate the c by moving a and b over, and then substitute c in for c. But I find that substitution takes a lot longer in these problems. So I'm going to stick to elimination. Again, if you love substitution, go ahead and try that on your own. Okay, so in order to eliminate something, I want to eliminate c again. Since I eliminated c here, I have an equation in terms of a and b. If I want to solve the system, I need another equation in terms of a and b. In order to eliminate c, I'm going to repeat the process I did before, and I'm going to multiply by negative 1. So I have my same equation, negative 7 equals negative a minus b minus c. And this equation can stay the same because the c's will eliminate just from multiplying the first equation. This is 9a plus 3b plus c. And I'm going to add my equations together. So negative 7 and 15 will give me 8. Negative a and 9a will give me 8a. 3b minus b, add those together, you'll get 2b. And like I wanted, my c's will eliminate. So now I have another two-variable equation. And I'm going to call this, so these are equations 1, 2, and 3. I'm just going to keep numbering because I find it helps to be organized to solve these. So we'll call this equation 4 and this equation 5. And by combining equations 1, 2, and 3, I came up with equations 4 and equation 5. And if I put equation 4 and equation 5 together, I have a two-variable system. So equation 4 is 33 equals 3a minus 3b. And equation 5 is 8 equals 8a plus 2b. Okay, so now I have a two-variable system by combining my three-variable equations into two-variable equations. So this is just a two-variable system, which you will solve just like you'd solve any other two-variable system. And I'm going to continue with elimination just because none of my variables are isolated. So in order to do elimination on this system, we want to eliminate either a or b so we can get one variable alone and we'll be able to solve for one value. Unfortunately, I'm going to have to multiply both equations because I can't just multiply this by like 1 or 2 because nothing will cancel here. But instead, if I multiply, I don't know, let's say I want to cancel out the b's. If I multiply this one by 2, I'll have negative 6b. And if I multiply this equation by 3, I'll have positive 6b. So if you multiply both equations, you can get equations that cancel out. So 33 times 2 gives me 66 equals 6a minus 6b. Okay, that's just a multiplied factor of this equation. These are equivalent because I multiplied everything. Okay, let's do the same thing to the second equation, equation number 5. I'm going to multiply it by 3, though. Remember to distribute the 3 to everything. That's a really common mistake, is like forgetting to multiply 3 by this 8 here. So note that in your notes. So 8 times 3 will give me 24 equals 24a plus 6b. Okay, now I have multiples of these equations, and I have positive 6b and negative 6b, so those will cancel, and I'll be left with one variable. Whew, it's a lot of work, right? Okay, so 66 and 24 is going to give me 90. 24a and 6a is going to give me 30a, and my b's cancel. Okay, to get a alone, I want to divide both sides by 30. So 90 divided by 30 is going to give me 3. So a is 3. Okay, so now I've solved for a. I can plug this back in to solve for b. Okay, so I'm going to want to plug this back into one of my 2-variable systems, because if I just plugged it into a 3-variable system, I would still have 2 variables. Okay, so I know a is 3. Let's plug it back into one of these equations here to solve for b. It doesn't matter which one. I'm just going to do the one that's over here because I have more room. Okay, so a equals 8 times 3 plus 2b. So solving that out, we get 8 equals 24 plus 2b. Subtract 24 from both sides, you'll get negative 16 equals 2b. So then negative 8 equals b. Okay, now this is starting to pick up the pace. I know it was kind of long to create that 2-variable system, but now it's just substituting in numbers and solving for your variable. So I know b is negative 8, a is 3. We can finally solve for c. And you can plug this into either equation or any of the 3 equations. I'm going to use the one that's easiest to save me the most time, and I think that this one, doesn't require too much multiplication. So I'm going to plug it into equation 2. 7 equals a plus b plus c. Okay, so 7 equals a plus b plus c. Substitute it in those numbers. So you get, let's see, 3 and negative 8 gives me negative 5. So that means c would be 12. Okay, now I have a, b, and c. I need to answer the final question. So it said, write the equation of the parabola that passes through the following 3 points. So I found my a, b, and c. Let's answer the final question. And I don't feel like scrolling up and down again, so I'm just going to write it up here. So we have y equals, my a, again, we said is 3. So it's 3x squared. My b was negative 8, so it's negative 8x. And my c, or my y-intercept, is 12. So I got my 3 variables, and I was able to plug them in to find the equation of the parabola. Okay, so that's how you solve a 3-variable system. I think the most important thing is to stay organized, because it's really easy to lose what you're doing. So ultimately, your goal is to turn it into a 2-variable system. I did that by combining 2 of the equations, and I got one of my 2-variable equations. And then I combined 2 more to get my other 2-variable equation. Because now this is really just a system in 2 variables, which then I treated like a system of 2 variables. I did substitution, elimination, whatever it is you want to do. Find one variable. Once you find one, you substitute it back in. Once you find the other, you substitute both variables back into one of the original equations to find your last variable. Okay, so it's not really anything new. It's just a couple extra steps to turn it into what you know. But substitution, elimination, graphing, like all those methods will come into play during this unit. I'm leaving one for you to try because I think this takes a lot of practice. So please do this on your own, test yourself, and please come with questions.